Can you see my whiteboard?
No, I'm not able to see it. Yeah, now I can.
Okay. Okay. So again, we are going to talk about integration. Okay, there's, yeah. Integration. And we were discussing the first topic, that was recognizing integrals. So I'll just be doing the last example from that topic. Okay. So what if you have been asked to integrate 1 over 4 x minus 1 dx, right? Now, I'm sure that you would be knowing how to integrate it. We can either take this whole thing to the numerator and do it in, a very basic way. But here we are not going to discuss that way. Here we have to recognize something. We need to assume that this function is the derivative function. So it is 1 over 4x minus 1. Now we need to think of an f of x such that when we derivate this f of x, we get this, right? So we need to think of such a function. So it is a fraction. And if I talk about some general derivatives, so if I have to derivate e to the x, I will get e to the x as it is. If I am asked to differentiate simple natural log of x, I would get 1 by x. And here 1 would come the power, the derivative of x, but since it is 1, so we don't write it, right? So we have some, this is rough work, and I have discussed some of the general derivatives. So what is your idea? What is your guess over here in our case? This is the derivative of which function? What do you think? It is a fraction. Just guess
4x
something.
minus 1. Yeah, 4x minus 1 to the power negative 2.
Okay, wait, let's see. 4x minus 1 to the power minus 2. So in that case, I would have had a minus 2 in the derivative, and this would have been minus 3. Okay, so this is not the case. And yes, very good. Guess something else now. I've done the rough work for your convenience. You can guess something from there as well. Okay, I'll tell you. What if we have what if we had natural log of 4x minus 1? The derivative in this case would have been 1 over 4x minus 1 into 4. The derivative of this function would be multiplied in the numerator, right? Do you remember this derivative?
Yes.
But in our case, we have this, right? So since we need a 4 in the numerator, we will basically divide 4 here, because then if we differentiate this function, I would have had a 4 in the denominator as well, and this would be cancelled. So then I would have this derivative, right? So if I have this derivative, this would be my function. This would be the integral. So this implies I'll have f of x plus c, and f of x is ln 4x minus 1 divided by 4 plus c. Is it clear?
Yes.
Okay, this is the answer. Are you sure it's clear?
Yes, it is.
So should we move on to the second topic?
Okay.
Okay. So it is because we have been discussing these integrals in last class as well. So yeah.
Yeah.
Integration. The chapter is same, the topic is different. So we will discuss 5.3. Integration using trigonometrical relationships. Okay, so here we will be focusing on trigonometry. In the previous unit, we were basically trying to recognize the derivative, right? We were finding the integral, but we were working on the derivatives more. As in the last example, we had a fraction. So we know that if this is the derivative, the function would be the logarithmic function, right? So this is what we were doing in the last section. But in this section, we will focus on trigonometrical relationships. Okay, so let's do it. Let's say you have been asked to integrate 5 secant square 0.2x plus 10 dx. Okay. Now, the first thing is to know that this is equivalent to this integral. Since 5 is constant, so I can take it out, right? We know this. Right,
Yes.
Ranjani? Very good.
Yes.
Okay. Now we need to focus on this part only, right? This is the focus part. Okay. So if I do some rough work, I can tell you that if we have, let's say, tan x, the derivative of tan x is basically secant square x. Okay, so in this case, f dash of x is, sorry?
Oh, f dash of x is yeah, tan.
No. F dash of x is the derivative, is the answer of derivative. Tan is the function that which is being derivated, right?
So that's x square x.
Yeah, do you understand this?
Yes.
So this is the relationship. Okay. We have this in our rough work and we need to think about this one. Now, in our example, the f dash is, what is f dash, Anjali, in my case, in our case?
Tan x.
No, I'm talking about this
Oh,
this
sec
thing.
x. Sec square.
So, yeah, and tell me the exact thing. Sec square
Sec
and
square x. Sec square
yeah.
0.2 x plus 10.
Okay. I'll tell you again. Okay, I'll give you a quick recap. We have already discussed that the integral of this derivative is basically f of x, right? So at the moment we are working on recognizing integrals as well as we'll be using trigonometry, right? So that this is, you need to be clear with this concept. This is the integral and this thing is the derivative. Okay, we are considering it as a derivative of some function that we will be finding. So this is the derivative, secant square 0.2x plus 10, and this is our previous knowledge. We know that we'll get secant square as derivative of a function if it is tan. So here my first guess is that this would be tan 0.2x plus 10. But then if I would have had this as my function, the derivative would have been secant square 0.2x plus 10, and then there's something is missing. What is that something? 0.2. Derivative of this function, right? If this was a function, we would have had secant square and this with 0.2 because derivative of this function would come here. But things are not like that. We only have this f dash of x. This means that we'll be having 0.2 in the denominator of f of x, and now if I differentiate, I will get this whole thing. I will get secant square 0.2x plus 10 divided by 0.2 into 0.2, and then the 0.2 would be cancelled, so I would get the same derivative if this is my function. So we know that the integration of this function basically implies f of x plus c. Okay, I'll tell you again. Now listen. This is our previous knowledge from the chapter of derivatives. We know that if I have tan x and if I am differentiating tan x, the derivative would be secant square x. Okay. So always remember, in this case, tan x is the function. This is the derivative. Secant square is the answer, right? Sec square is the answer of the derivative. So this is the derivative function. And this tan x is the simple function. Okay. So this is our previous knowledge. Another thing which we are talking about since yesterday, that if you have integral with a dx here, obviously you will have the function that is coming, that is being integrated should be considered as a derivative, because this section focuses on recognizing integrals. Okay. So for this section only, you need to recognize this integrand. You need to think of it as a derivative. You need to think that this function which you have been asked to integrate is basically a derivative. And then the second question would be that, okay, if it is a derivative, which function's derivative is it? In our case, we had secant square 0.2x plus 10. And we know that secant square x is the derivative when tan x is the function. So my first guess was that yes, we'll have tan and whatever I had in the theta part. This is the theta part, you already know that. But if I would only have this, there should have been a 0.2 here. Since we do not have a 0.2 here, it means we would have a 0.2 in function in the denominator, because then this 0.2 and the 0.2 would have been cancelled. Right?
Yes.
Do you understand it clearly 100%?
Yes, I do.
Okay. Then you have to help me with the with this one. Okay. Second example is sine square x dx. Now, what if I ask you to integrate this? How would you do it? Okay, I'll tell you. We have discussed.
Be negative.
Hmm?
No, it'll be cos x, cos square x.
Cos square x. Are you sure? Okay, wait. First thing is that we are not integrating it the way we usually do, right? You need to recognize this thing. Okay, you need to recognize this as a derivative. The second thing is that even if we are doing it directly, I told you already that if you are differentiating, let's say sine square, you cannot say that the derivative of sine square is cos square x. No, this is not the case. You will first write 2
So,
sine x and then the derivative would come in, that is cos x. So again, in case of integration, you will be dealing such questions that way as well, that you'll think of the sine square x like this, and then this power we'll add 1, and whatever way we integrate. Here we are not doing it that way basically, but if we do it, so this would be done this way, and then we'll divide the derivative of sine x, right?
yes.
This is how you would have attempted this, but you are not going to do it this way. Okay, right. So the first thing is you need to recognize this. You need to think of it as a derivative. Have you ever seen a derivative of this type? Have you ever seen sine square as derivative of any function? Like we have seen sine, we have seen cos, we have seen so
Not sine
many.
square. We have to use the bracket rule.
No, no. Yes, you would have used the bracket rule if we were doing it that way. Okay. Here we need to recognize the integral. So sine square, we will not use sine square here. This basically is equal to, here we'll use trigonometry, right? I'll tell you. If we know that cos 2x equals 1 minus 2 sine square x. Okay. So we'll have 2 sine square x equals 1 minus cos 2x. Sine square x equals 1 minus cos 2x by 2. You need to replace this first because you are not being able to recognize any derivative this way. This is not a derivative.
Can you please repeat it?
Okay, I definitely can. This is basically trigonometry. Have you studied different trigonometrical identities?
Yes, I have.
So are you familiar with this one?
Yes.
Okay, very good. So we know that cos 2x equals 1 minus 2 sine square x. But before going to this part, you have been asked to integrate this, right? We are discussing the section of recognizing integrals.
So we are not integrating it. We are just recognizing that you can integrate it or something.
No, no, no. We are integrating it. We have been integrating it in the previous in the previous question as well, and yesterday as well. We are basically integrating it, but we are doing it through this method. We are first going to recognize we are first going to recognize this integrand as a derivative. This is the integrand, okay? The thing which we are integrating is the integrand, and we need to think of it as a derivative. This is what we have been discussing, right? We just have already discussed this yesterday as well, that in this section we are basically doing things this way, that you have been asked to to integrate a function, and you need to think of this function as a derivative, and it would be derivative of a function. F dash is derivative of f of x, so f of x is the answer in our case. So in our given example, we have sine square x, right? Sine square x itself is never seen seen as a derivative anywhere. You would agree, definitely, right?
Yes.
Sine square x is not a derivative, okay? So we need to replace this sine square x with something else. So we have used trigonometry here. We need to replace sine square x with this, thing. Do you get it now?
Yes, I do.
Okay. Wait a second. Wait a second. I'll explain you again. Okay. Wait. We are basically discussing the topic of recognizing integrals, and you have a function here. Let's say it is 2x, right? Dx. Now, if you integrate it directly, right? If you integrate it the way you know, the way you have been doing, you will say this would be 2 integral of x dx. This would be 2 would come as it is, x to the 2 plus c. Agreed? This is how you would integrate this function?
Yes.
Okay. This is absolutely correct. But here we are discussing recognizing integrals. You need to think of this function as a derivative. You need to think of it that this f dash, this 2x is basically derivative of some function. And you need to start your guesswork. You need to think that, okay, if you were differentiating x square, you would get 2x. So this is how you end up getting your answer. This f of x is basically the answer of this integral. So you had 2x dx, it would be x square plus c. Yeah, we had 2 over here. This 2. Do you get it?
Yes.
Okay. So this is the function, this is the question. You need to integrate this, right? So this is basically our
Yeah.
what is this?
F dash of x.
Very good. What is the second step?
1 minus cos square x.
Yeah, okay. Yes, this is also a trigonometric identity, but if you will use 1 minus cos square x, again the question would come on cos square x, okay? So if you use this identity, if you use sine square x plus cos square x equals 1, this would not help you, because you will end up getting 1 minus cos square x, and again you will be integrating it, and again you'll think of a derivative. Cos square is not a derivative. You know that, right?
Yes.
So we basically convert this to 1 minus cos 2x by 2 dx. Now you need to basically you will have 1 by 2 minus cos 2x by 2 dx, and now you will write down 1 by 2x minus, what is the integration of this? Okay, so you have, what if you have this? What if this is your f derivative function, right? What if you have cos 2x by 2 as your derivative function, and you have been asked to find the integral? So you need to think of a function whose derivative is this. So it would be sine, definitely, sine 2x, right? Agreed? It would be sine 2x, but there's another problem. If you had sine 2x and you were asked to differentiate it, you would have ended up getting cos 2x with a 2 here. But there's no 2 here. There is no 2 over here. So you will basically divide a 2 over here. Because now if you differentiate this function, you will get this. And now this derivative has a 2 in the denominator. So you need to have a 2 here, because then you will have 2 here, and this matches this derivative, and you have differentiated this function to get this. And the underlying logic is f dash x dx equals f of x. Do you agree?
Yes.
So you need to do the guesswork here. Okay, so this would be minus sine 2x 2 into 2 plus c. So this would be 1 by 2x minus sine 2x divided by 4 plus c. You need to understand this nicely, because I want you to do the cos square x1, right? So I can explain this to you again. Now I repeat. This is how our question started. Sine square x cannot be used directly. We need to convert it to another or to a simplified version. And this is 1 minus cos 2x by 2, right? We simplified it further, and now we were left with this part. Now we need to think of this as a derivative, and we need to think of a function whose derivative would be cos 2x by 2. So here is our guesswork. We considered cos 2x by 2 as derivative, and initially we said that okay, sine 2x could be that function. But if we had sine 2x and if we differentiate it, we would get cos 2x into 2. This 2 was missing, so we basically divided it a 2 over here. So this problem was solved, but then we had this 2 over here, so we multiplied another 2 in the denominator, and now if I differentiate this function, I would get this one. So we had this logic, and through this logic we basically have calculated the integral. Do you get it?
Yes.
Okay, very good. So then just integrate it. Okay, I can give you 3 minutes. Just try integrating it. I'll stop the recording because that would, oh sorry. You have you noted this question down? You need to integrate cos square x. Okay, I'll stop share. I'll stop the recording, and then I'll